Hi everybody, it's Mrs. Peachy from your WCA physics class. We are going to looking at resolving vectors today, and also what resultant vectors are. So those two things we're going to be looking at, resolving vectors and resultant vectors from Unit 1 of your physics class here at WCA. So I'm going to draw your attention now to my notebook. So I'm going to put my camera face down. I'm going to give us a full screen view of that and flip it around so that you guys can see a little bit better. And you should be able to see my notebook pretty clearly here. So remember that vectors are showing us kind of graphing the motion of an object. And when we draw vectors, we can draw an arrow indicating like which direction that object is moving. So for example, we might say that an object has moved has moved 4 meters to the east, 1, 2, 3, 4, turned and moved 3 meters to the north, 1, 2, 3. What is the total displacement of that object? Okay, so this is something we've talked about before. So this is the 4 meters to the east, 3 meters to the north. Total displacement means we would connect these together, and you would end up with your total displacement right here, right? Then using the Pythagorean theorem, we could do 3 squared plus 4 squared equals, in this case, we'll call this d for total displacement, equals d squared. And this is just this is a perfect triangle, so this is a 3, 4, 5 triangle if you already knew that from geometry. Otherwise, you could solve here and you'd end up with 9 plus 16 is equal to 25, with the square root of 25 to give us d, right, which is 5. So this tells us that the total displacement here is 5. So that's something we've already kind of learned. Let's review. Resolving vectors kind of is like going backwards. In the case of resolving vectors, rather than being given the x and y motion, we're trying to figure it out. So, for example, we might say that a helicopter was traveling 95 kilometers per hour at an angle of 35 degrees to the ground. So 95 kilometers per hour, we can measure this angle at about 35 degrees. I'm just going to estimate. Okay, so 95 kilometers per hour. This angle measure is 35 degrees. And then you need to resolve both the x and y velocity vectors here, because we know that if something is moving diagonally, it has velocity in both the horizontal and vertical direction. It's a combination of those two velocities that produces its diagonal velocity here. Okay, so how do we resolve them? You're just going to drop a vertical back down to the x-axis, and we're going to look at both of these components. This is our x and this is our y, and we use basic SOHCAHTOA trig functions here. So the sine of 35 is equal to y over 95. And the cosine of 35 is equal to x over 95. So we can solve these. 95 sine 35 equals y. 95 cosine 35 equals x. And so when you resolve the vectors, you're pretty much going to work that same methodology all the time. So sine of 35 times 95 gives us 55 or 54.5 for our y. Yep. And for our x, cosine 35 times 95 gives us 77.8. Okay. Kilometers per hour, kilometers per hour. So we were able to resolve those two components. That becomes useful when we start doing more complicated problems where we will need these components to then be able to solve for, say, maybe you need to get, looking for an object's velocity with projectile motion, or how far it's moved in the x direction, or something to that effect. Okay, so that becomes useful a little bit later on, but it's a skill that's going to help to get you to that endpoint. Right, so that's resolving vectors. Just an example. If you have questions or concerns, feel free to contact me at extension 2204. Have a great day.